For over 180 million years, dinosaurs in all their majestic forms ruled our planet. From the colossal Argentinosaurus, a titan stretching over 100 feet, to the swift velociraptor, a formidable predator with a deadly claw, these creatures thrived in diverse ecosystems. Then, 66 million years ago, their reign abruptly ended. The dinosaurs, along with countless other species, vanished from the face of the earth, leaving behind only fragmented bones and tantalizing clues. The cause of this mass extinction, the most famous in our planet's history, has been a subject of intense scientific debate and public fascination. Today, we delve into the heart of this prehistoric enigma, exploring the three leading theories that attempt to explain the dinosaurs' demise. Was it the cataclysmic impact of a giant asteroid, a celestial hammer blow that reshaped our planet? Or could it have been the relentless fury of volcanic eruptions, spewing forth toxic gases and altering the very climate itself? Perhaps a more insidious threat, a microscopic enemy spread through these magnificent creatures, weakening them and paving the way for their extinction. Join us as we unravel the threads of this ancient mystery and consider the possibility that it wasn't just one single event, but a perfect storm of calamities that brought about the end of the dinosaurs.
Our journey begins with a scar on the Earth's surface so vast that it speaks volumes about the catastrophic event that transpired millions of years ago. This scar is not just a geological feature, it is a silent witness to one of the most dramatic chapters in Earth's history, a moment that reshaped the trajectory of life itself. This is the Chicxulub crater, a sprawling impact site located on the Yucatan Peninsula in Mexico. Its discovery unraveled a story of cosmic violence and planetary transformation. Buried beneath layers of sediment, this 110-mile-wide crater lay hidden for millennia, unknown to the human eye until its discovery in the late 1970s. It was only through the meticulous work of scientists that its secrets began to surface. Geologists, piecing together evidence from drilling cores and seismic surveys, revealed the telltale signs of an impact event of unimaginable scale. The clues they uncovered painted a vivid picture of destruction and renewal. The culprit, they determined, was an asteroid, a celestial wanderer at least 6 miles wide, that collided with Earth at a staggering speed. This asteroid, traveling faster than a bullet, carried with it the power to alter the destiny of an entire planet. The energy released upon impact dwarfed that of all the world's nuclear arsenals combined, unleashing a wave of destruction that rippled across the globe. The sheer magnitude of this energy is almost incomprehensible, a force capable of reshaping continents and rewriting ecosystems.
The immediate aftermath of the asteroid's impact was nothing short of apocalyptic. The Earth was plunged into chaos, with the natural order disrupted on an unprecedented scale. The colossal energy release ignited wildfires that raged across continents, consuming entire forests and turning once lush landscapes into desolate wastelands. These fires burned with an intensity that left no room for survival in their path. The searing heat from the impact vaporized rock and sent billions of tons of debris hurtling into the atmosphere, blanketing the planet in a suffocating shroud of dust and ash. This veil of destruction would linger, altering the planet's climate for years to come. This debris, propelled to unimaginable heights, rained down upon the Earth, burying ecosystems and choking out any life that had survived the initial blast. The planet was transformed into a hostile environment, unrecognizable from what it had been before.
The impact's fury wasn't confined to the land. The oceans too bore the brunt of this cosmic collision. The asteroid's collision with the shallow waters of the Yucatan Peninsula unleashed a series of monstrous tsunamis, towering walls of water that surged across coastlines with unimaginable force. These waves carried destruction far beyond the initial impact zone. These colossal waves, some estimated to have reached heights of over a mile, swept inland for hundreds of miles, drowning entire islands and reshaping continents. The very geography of the Earth was altered in the wake of this event. Coastal ecosystems, home to a rich tapestry of life, were obliterated in an instant, leaving behind a trail of devastation in their wake. The loss of biodiversity was staggering, a stark reminder of nature's fragility.
As the fires subsided and the tsunamis receded, the long-term consequences of the impact began to take hold. The Earth was entering a new and challenging chapter in its history. The massive amount of dust and debris injected into the atmosphere cast a dark veil over the planet, blocking out the sun's life-giving rays. This darkness was both literal and metaphorical, signaling the end of an era. This impact, winter, as it's known, plunged the Earth into a prolonged period of darkness and cold. The planet's climate was thrown into turmoil, with temperatures dropping to life-threatening levels. Temperatures plummeted, and photosynthesis, the very foundation of most life on Earth, ground to a halt. The interconnected web of life began to unravel at an alarming pace.
With the sun's energy extinguished, the planet's delicate ecosystems began to unravel. The balance that had sustained life for millions of years was irreparably disrupted. Plants withered and died, depriving herbivores of their food source and setting off a chain reaction that would decimate entire food chains. The collapse of these ecosystems was swift and merciless. Without vegetation to sustain them, herbivorous dinosaurs, even the mighty sauropods, succumbed to starvation. Their extinction marked the end of an era of giants. Carnivores, reliant on prey that was rapidly vanishing, soon followed suit, their reign as apex predators brought to a brutal end. The food web that had sustained them was gone.
The Chicxulub asteroid impact stands as a chilling reminder of the immense power that lies beyond our planet. It is a testament to the fragility of life and the forces that shape our world. It was an event of such magnitude that it forever altered the course of life on Earth, wiping out the dinosaurs and paving the way for the rise of mammals. The world that emerged was vastly different from the one that had been lost. Yet, amidst the devastation, life found a way to endure. The resilience of nature is a powerful force, capable of overcoming even the most catastrophic events. The impact, while catastrophic, also created opportunities for new species to evolve and thrive in the dramatically altered environments that emerged. Life, as it always does, adapted to the new normal. The extinction of the dinosaurs, while tragic, ultimately paved the way for the emergence of our own species, Homo sapiens. From the ashes of destruction, a new chapter in Earth's story began.
Our investigation into the extinction of the dinosaurs takes us now from the site of a cataclysmic impact to a region shaped by the relentless power of volcanoes. This journey takes us deep into Earth's geological past, where the forces of nature sculpted a landscape that would forever alter the course of life on our planet. Deep within the Indian subcontinent lies the Deccan Traps, a vast volcanic landscape bearing witness to one of the most significant volcanic events in Earth's history. This region, with its layered basalt formations, tells a story of immense geological upheaval and transformation. Spanning an area larger than France, the Deccan Traps are a testament to the Earth's fiery underbelly, a place where molten rock once surged through fissures in the crust, spewing out lava flows that stretched for hundreds of miles. These flows, layer upon layer, built the immense plateaus we see today, a stark reminder of the planet's volatile past. These eruptions, which began long before the Chicxulub impact, continued for nearly 1 million years, releasing unimaginable quantities of volcanic gases and ash into the atmosphere. The scale and duration of this activity were unlike anything seen in modern times.
While the Deccan Traps eruptions may not have possessed the immediate explosive power of the asteroid impact, their sustained activity had a profound and devastating impact on the planet's environment. Over time, the cumulative effects of these eruptions reshaped ecosystems and altered the trajectory of life on Earth. The volcanoes belched out a toxic cocktail of gases, including sulfur dioxide and carbon dioxide, potent greenhouse gases that had a dramatic effect on Earth's climate. These emissions created a cascade of environmental changes that rippled across the globe.
Sulfur dioxide, released in vast quantities, reacted with water vapor in the atmosphere to form sulfuric acid aerosols. These aerosols, though microscopic, had an outsized impact on the planet's climate. These aerosols, suspended in the stratosphere, acted like a giant sunshade, reflecting sunlight back into space and causing global temperatures to plummet. This phenomenon, known as volcanic winter, would have had dire consequences for life on Earth.
The Deccan traps eruptions through their relentless outpouring of greenhouse gases wreaked havoc on Earth's delicate climate balance. The interplay between cooling and warming effects created a chaotic and unstable environment. The massive influx of carbon dioxide trapped heat within the atmosphere, leading to a gradual but relentless warming effect. This warming, though slower than the cooling caused by aerosols, had long-term implications for the planet's ecosystems. This warming, coupled with the cooling effects of the sulfuric acid aerosols, created a turbulent and unpredictable climate, characterized by extreme temperature swings and disrupted weather patterns. Such instability would have made survival increasingly difficult for many species.
Marine ecosystems, particularly sensitive to changes in ocean acidity, suffered greatly as carbon dioxide dissolved in seawater, leading to ocean acidification. This process disrupted the delicate balance of marine life. This acidification had a devastating impact on shell-forming organisms, such as plankton and corals, disrupting marine food webs and causing widespread ecological collapse. The oceans, once teeming with life, became increasingly inhospitable.
The prolonged period of volcanic activity and its associated climate change placed immense stress on ecosystems worldwide. The interconnectedness of life meant that no species was left untouched by these changes. Plants and animals struggled to adapt to the rapidly shifting environmental conditions, with many species facing extinction. The resilience of life was tested to its limits. The Deccan traps eruptions, while not delivering a single knockout blow like the Chicxulub impact, delivered a series of debilitating punches that weakened the global biosphere. This prolonged assault left ecosystems vulnerable and fragile. This prolonged period of environmental stress may have left dinosaurs particularly vulnerable to the Chicxulub impact. Their ability to adapt and survive was already compromised. Already weakened by volcanic activity, they were ill-equipped to cope with the sudden, catastrophic environmental changes brought about by the asteroid. The combination of these events proved to be too much for the dinosaurs to endure.
Some scientists believe that the Deccan traps eruptions, through their long-term impact on climate and ecosystems, may have played a more significant role in the dinosaurs' extinction than previously thought. This theory continues to spark debate and research within the scientific community. They argue that the impact, while undoubtedly devastating, may have been the final blow to an already weakened and vulnerable dinosaur population. The interplay of these forces paints a complex picture of extinction. Fossil evidence suggests that dinosaur diversity may have been declining for millions of years prior to the Chicxulub impact. This decline, coupled with the environmental stress of volcanic activity, may have sealed their fate. This decline, coinciding with the Deccan traps eruptions, suggests a possible link between volcanic activity and the dinosaurs' ultimate demise. The evidence points to a multifaceted extinction event.
The Deccan traps eruptions present a compelling case for the role of volcanic activity in shaping Earth's history and influencing the fate of species. Their legacy is etched into the very fabric of our planet. While the Chicxulub impact undoubtedly played a significant role in the dinosaurs' extinction, the Deccan traps eruptions may have set the stage for their demise, weakening them and making them more susceptible to the impact's devastating effects. Together, these events created a perfect storm of destruction. The extinction of the dinosaurs, rather than being a single event, may have been the result of a complex interplay of factors, a perfect storm of celestial and terrestrial forces that conspired to bring about the end of an era. The story of extinction is a reminder of the fragility of life and the power of Earth's natural forces. Life on Earth, even for creatures as mighty as the dinosaurs, is a delicate balance. The intricate web of ecosystems, predator-prey relationships, and environmental conditions all play a role in maintaining this balance. Yet even the most dominant species are not immune to the forces of nature that can tip this balance. While catastrophic events can reshape the world in an instant, other more insidious threats can weaken populations over time, making them vulnerable to collapse. These threats often go unnoticed until their effects are too severe to ignore. Could disease, a silent killer, have played a role in the demise of the dinosaurs? This question has intrigued scientists for decades as they piece together evidence from the fossil record. The fossil record, while incomplete, offers tantalizing clues. Each fossilized bone, each preserved fragment, tells a story of life, struggle, and survival in a world long gone. Evidence of parasites, infections, and even bone cancers suggests that dinosaurs, like all living creatures, were susceptible to a range of ailments. These diseases may have been as varied and complex as the ecosystems the dinosaurs inhabited. These diseases, though perhaps not immediately lethal, could have weakened individuals, impacting their ability to find food, reproduce, and survive. Over time, such vulnerabilities could ripple through entire populations. Imagine for a moment a vast herd of hadrosaurs migrating across continents in search of fresh vegetation. These migrations were likely essential for survival, but they also came with risks. Among them, individuals weakened by disease struggle to keep pace, their immune systems compromised. These stragglers would have been easy targets for predators, further reducing the herd's numbers. A sudden change in the environment, maybe a drought or a new predator, could prove catastrophic for these already vulnerable creatures. The combination of environmental stress and disease could have created a deadly feedback loop. Disease outbreaks are more likely in densely populated areas where pathogens can spread rapidly through close contact. The social behavior of dinosaurs, such as herding, may have inadvertently facilitated the spread of diseases. The late Cretaceous period, the final chapter in the dinosaurs' reign, saw the emergence of vast herds of herbivorous dinosaurs, their numbers reaching unprecedented levels. This abundance, while a sign of their dominance, may have also been their Achilles heel. This crowding could have created ideal conditions for the spread of infectious diseases. Pathogens thrive in such environments, exploiting the close proximity of hosts to jump from one individual to another. Furthermore, dinosaurs, like many modern animals, may have engaged in long-distance migrations, potentially carrying diseases across continents. These migrations could have introduced pathogens to new regions, affecting previously unexposed populations. A sick individual carrying a novel pathogen could introduce it to new populations, triggering widespread outbreaks with devastating consequences. Such outbreaks could decimate herds, leaving survivors struggling to rebuild. The impact of such outbreaks on dinosaur populations remains a subject of debate. While some argue that diseases alone were not enough to cause extinction, others believe they played a significant role in weakening populations. Some scientists believe that diseases, while potentially weakening individuals, were unlikely to cause extinction on their own. However, when combined with other stressors, their impact could have been profound. Others, however, argue that widespread epidemics could have significantly reduced dinosaur numbers, making them more susceptible to other environmental pressures. The interplay of disease and environmental change may have been a critical factor in their decline. The microscopic world, teeming with bacteria, viruses, and parasites, has always played a crucial role in shaping life on Earth. These tiny organisms, invisible to the naked eye, wield immense power over the survival of species. The extinction of the dinosaurs, a pivotal event in Earth's history, continues to captivate our imaginations. The Chicxulub asteroid impact, a cataclysmic event that forever altered the course of evolution, undoubtedly played a significant role in their demise. However, as we have explored, the dinosaurs' extinction was likely not a singular event, but rather the culmination of multiple environmental pressures. Volcanic eruptions spewing forth toxic gases and altering the global climate likely weakened ecosystems and placed immense stress on dinosaur populations. Disease, too, may have played a crucial role, with widespread epidemics potentially weakening dinosaur populations and making them more susceptible to other threats. The exact combination of factors that ultimately led to their extinction may forever remain a subject of scientific debate. Yet the story of the dinosaurs serves as a powerful reminder of the interconnectedness of Earth's systems and the fragility of life in the face of environmental change. What can we learn from the dinosaurs' extinction to better understand our planet's future? This is a question that continues to challenge and inspire us.